Question 8. You're going to try to use a patient's age, annual income, and their blood sugar levels to try to predict how many days in the hospital that they might spend. Okay, this is a regression model, multiple regression model. So let me go ahead and pull up the data. There's the data. So just like always, you're going to go to data, data analysis. And like I just said, it's a regression model. Click regression. Your Y range is your criterion. It's your DV. What are you trying to predict? You're trying to predict days in hospital. That is your Y range. Your X range, click there. Go ahead and click all 3 columns. Click and drag. And I want the output range to be in the same place as always, right around H5 or something. So I can see it on the same page. And I don't want the rest of that stuff. Click OK. There it is. Give me a second. And again, I've color coded. So age is variable 1, income is variable 2, blood sugar is variable 3. So here's all the data. I'm looking at the R squared. This is your effect size. It's 0.71, which is huge. So in other words, you can explain about 71% of the variance in hospital stays based on, the variables, age, income, and blood sugar. Very impressive. It is a significant regression, right? The ANOVA tells us so. And this table right here, p-values, tell you which of the variables is significant. So if it's less than 0.05, it's significant. So they look like they're all significant. Again, there's the p-values for each one, and they're all less than 0.05, so they're all significant. And unstandard is B's weights. I'm going to have to show you that in SPSS. But let's go back and answer our questions. So what's the null? Null is there's no significant regression models ever, right? The predictors will not predict. That's what the null says. The DV is we're trying to predict how many days in the hospital a person will spend, and the IVs are the predictors are based on age, annual income, and their blood sugar level. Okay, the effect size was 0.71. That's your R squared. That's a very strong. That makes this an accurate model. And it's a significant regression because the ANOVA tells us so, right? The ANOVA was significant. Therefore, the regression model is believable. And was age a significant predictor? Yes, because the p-value was less than 0.05. Annual income a significant predictor? Yes, because the p-value was less than 0.05. Blood sugar, same thing. Significant predictor because the p-value is less than 0.05. Which predictor was strongest? Excel doesn't do that. Let me show you why. There are no standardized beta weights here, but there will be on SPSS. So hold on one second. So I transferred the data from Excel. So now we're going to go to Analyze, Regression, Linear. Get in there, you. And what are we trying to predict? Days in hospital. These other 3 are the independent variables. Predictor variables. Go to statistics. We want all of these checked. Durbin-Watson is a test that I'm not going to go over with it because we don't have enough time. But there's our output box. This should basically be the same thing as the Excel. But what we need here is the standardized beta coefficients right here. This one tells you which one. This tells you which of the predictors is the strongest. And according to this, it's the blood sugar that is the strongest. They're all relatively strong, but blood sugar is the strongest because it has the highest beta weight. So I think that answers all our questions, right? So blood sugar was the big one. Oh, no, we have to make a prediction equation. So what we're going to do is predicted Y. That's like a Y hat or a Y dot. Anything with over the Y tells you it's going to be a predicted model. We use the unstandardized B weights, okay? That is your coefficient for your X1 value, which is your age value. This is your coefficient for your X2 value or your annual income. And this is your blood sugar coefficient, 0.47 times whatever that is. And don't forget to add your constant. This is when you would add your constant in, -70. Okay, So let me show you with a model. We're going to make a prediction. How many days in the hospital would you expect if somebody was 58 years old, made 52G a year, and had a blood sugar level of 92? So you simply place these values into your equation model, and you get a final predicted of somewhere around 15 days. So that's it. MGZ out.